In this problem, we want to find the power supplied and the average power absorbed by each element in the circuit. So, for the inductor, we know the inductor doesn't absorb any average power, and also the same is true for the capacitor. Okay. So we know that the average power absorbed by the inductor and capacitor are both 0. Now we need to do some analysis on the circuit to be able to calculate currents through the resistors, voltage across the current source. So let's start off and say, okay, here are two impedances in parallel. I'm going to combine them into an admittance Y. So Y is 1 over J2 plus 1 over 2 minus J2, which is 0.25 minus J 0.25. And then Z, which is 1 over Y then, is 2 plus J2. So now, let's redraw the circuit, showing that combination. So there's our combination that we just calculated. Okay, now, again, we've got two impedances in parallel. And I'm going to also call that Y. Let's combine those in the parallel. So we have 1 over 4 minus J2 plus 1 over 2 plus J2, which is 0.45 minus J 0.15. So now the equivalent impedance to that admittance we just find by taking the reciprocal. So we have 2 plus J 0.667 ohms. Okay, so now our circuit has been reduced to the following. And now I'm going to calculate the voltage Vs here. This is going to be the voltage across our current source, that we can use that for calculating the power supplied by that. So Vs then is 2 at an angle of 0 times 2 plus J 0.6667, and that tells us that Vs is 4.22 at an angle of 18.43 degrees. Okay, so now that's that calculation. Now we can begin to back up. Okay, so for instance, here is the voltage Vs on our diagram. And now we can do some additional calculations. For instance, we can calculate currents now. For instance, we can calculate this current I1. Okay, and doing our calculations, I1 then is Vs divided by 4 minus J2. So we have 4.22 at an angle of 18.43 degrees over 4 minus J2. So then I1 is 0.943 at an angle of 45 degrees. Okay. And also, we can calculate another current here we'll call I0. Okay. So I0 is Vs over 2 minus J2. So we have 4.22 at an angle of 18.43 divided by 2 minus J2. So then I0 is 1.49 at an angle of 63.4. Okay, so there's our two currents. Now, we know we've already calculated that the average power for the inductor is 0, and the average power for the capacitor is 0. So for the 4 ohm resistor, okay, so for the 4 ohm resistor, okay, so if we look, the current I1 flows through it. So we have 1/2 times 0.943 squared times 4, which is 1.78 watts. Okay, so now for this 2 ohm, let's think for a second, we'll go back. This 2 plus J2 came from this parallel combination. The only average power over here is this resistor. So when I go through and do this combination and get a 2 plus J2, the power dissipated in here absorbed by that resistor is the same as the power dissipated in that resistor, because the inductor capacitor don't absorb any average power. Okay. So for the 2 ohm, we have 1/2 times 1.49 squared times 2, which is 2.22 watts. And if we look, if we add that up, I believe we'll get 4 watts. Now that should be what we would get when we calculate it for our current source. And if we look at our circuit, we can take 1/2 Vs times I times the cosine of the angle between them. So the power supplied by our source then is 1/2 times 4.22, that's the voltage across the source, times 2 times the cosine. We have 18.43 minus 0, so that gives us 4 watts for the power supplied, and obviously these two are equal, and they should be.